The price P in dollars and the quantity X of widgets sold obey the demand equation given. Find a model that expresses the revenue as a function of the number of widgets sold, X. We will start with the equation R equals XP. That's revenue equals X, the number of widgets, times P, the price. And since we want a function in terms of X, we want to replace P with an equation in terms of X. Fortunately, we were given the demand equation to begin with that we can use to replace P. So we have R equals X, replace P with negative 1/6 X plus 100. And then if we simplify this, we get R of X equals negative 1/6 X squared plus 100X. And we now have revenue as a function of X. Part B is asking, what is the revenue if 90 widgets are sold? Here we're going to simply plug in 90 to our function. So negative 1/6 times 90 squared plus 100 times 90. If we throw that into our calculators, we will get $7,650. Part C, what is the quantity that maximizes revenue? Notice that the revenue function from part A is a quadratic and it's opening down. So that means we have a maximum somewhere. We're looking for where that max occurs. That's the vertex of the parabola. To find the vertex, we use x equals negative b over 2a. So negative b in the r function is 100 over 2 times a, which is negative 1/6. And this gives us 300. So that's 300 widgets. Up next, we want to know what is the max revenue. To find that, we will simply plug 300 into the revenue function. Evaluate R at 300. Negative 1/6 times 300 squared plus 100 times 300. And here we get 15,000. And that's dollars. And the last question wants to know what price should the company charge to maximize the revenue. So we know the number of units we need to sell, 300. We know what the max revenue will be, 15,000. But what is the price per widget that we need to sell for? The shortcut would be to take the max revenue, 15,000, and divide that by the number of widgets, 300, and this gives us $50. An alternate way to approach this is to remember that you were given the demand equation at the very beginning. That's P equals negative 1/6 X plus 100. We can use this to find the price as well. So P is equal to negative 1/6 times X, the number of widgets we found to be 300, plus 100. And this gives us a price of $50. Beth has 3,000 feet of fence available to enclose a rectangular field. Express the area as a function of X, the length of the field. So we have a rectangle. The length is X, the width we'll call Y. The area of a rectangle is A equals X times Y. We need area to be a function of X. That means we need to replace Y using another equation. This time you're not given another equation, so we have to create one. The only other thing that we know about this shape is we know the perimeter. And the perimeter of a rectangle is 2x plus 2y. The perimeter we're told is 3,000 feet. So we can replace P with 3,000. And now our goal is to isolate the y. So we'll subtract 2x on both sides. And then divide by 2. We get 1,500 minus x equals y. So we can replace the y now in the area function with 1,500 minus x. Then if we distribute this, we'll get area as a function of x. 1,500 x minus x squared. Notice that equation is quadratic, and if we were graphing it, it would be opening down, which means it has a maximum. That vertex is at a max. Part B, we want to find the x value that makes the largest area. So we're finding the x coordinate of that vertex. The way to do that is x equals negative b over 2a. Looking at our function, b is 1,500, so we have negative 1,500 divided by 2 times a, which is negative 1. This gives us 750 feet. So the length of the field that maximizes the area is 750 feet. And then part C, what is the largest area? We want to plug in 750 into the area function. So we have 1,500 times 750 minus 750 squared. This gives us an area of 562,500 square feet. A farmer with 4,000 meters of fencing wants to enclose a rectangular plot that borders a river. If the farmer does not fence the side along the river, express the area as a function of x, the length of the field. So this time we have fencing on 3 sides, but there's a river on one side that does not need fencing. We'll call the length of the field x, and the width we can label as y. Area of a rectangle is length times width, or x times y in our case. We want to replace the y with another equation so the area will be written in terms of x. We need to create that other equation. Fortunately, we know that the perimeter is x plus 2 times y. This time we don't double the x because the river side does not need fencing. Perimeter we know to be 4,000. So we have 4,000 equals x plus 2y. And now solving for y, we subtract x, and then we'll divide by 2. So we have 2,000 minus 1/2 x equals y. We can now use this equation to replace y in the area equation. Y is now 2,000 minus 1/2 x. And then simplifying this equation, area is now written as a function of x. 2,000 x minus 1/2 x squared. Notice that the area function is a quadratic. It's opening down. So if we graphed it, it would be a parabola that has a maximum. Part B, what is the value of x that makes the largest area? So here we're looking for the x value of that vertex. The equation is x equals negative b over 2a. B in this case is 2,000. So we have negative 2,000 divided by 2 times a, which is negative a half. This gives us 2,000 meters. In part C, we're looking for the largest area that can be enclosed. So here we will evaluate the area function at the 2,000 that we just found. So we have 2,000 times 2,000 minus 1/2 times 2,000 squared. This gives us 2 million square meters for the max area. H of x models the path of a projectile. X is the horizontal distance from the firing point. Part A. At what distance from the starting point does the projectile reach its max height? Notice that H is a quadratic. If we graphed it, it's opening down, and it has a max. To find the vertex, the maximum of that quadratic, we use x equals negative b over 2 times a. In this case, b is 1. Then we have 2 times a. A is the fraction negative 32 over 10,000. Simplifying this, we get 156.25. To find the max height, we evaluate the function h at 156.25. That is negative 32 divided by 10,000 times 156.25 squared plus 156.25. This gives us 78.125. And part C, at what horizontal distance will the projectile strike the ground? Here we want the height h to be 0. That's when it strikes the ground. So we'll just set the function equal to 0. So we have negative 32 over 10,000 x squared plus x. And our goal here is to solve this quadratic. Since this is not easily factorable, probably the easiest way is to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a c all over 2 times a. Notice that this piece is just going to go away to 0. So we have negative 1 plus or minus the square root of 1, which is 1, all over 2 times negative 32 over 10,000. So we have two options here. We can use the negative 1 plus 1 or negative 1 minus 1. Negative 1 plus 1 in the numerator will give us 0. We don't want that one because 0 means that it's starting on the ground. We want to know when it strikes the ground. So we're going to be using the -1 minus 1 over 2 times -32 over 10,000. And this gives us 312.5. This is where the projectile strikes the ground.